Hi, my name's Steve Ward and I'm doing a PhD in materials chemistry at Newcastle University. My project and research interest is based around the design of materials for what's known as the electrochemical splitting of water into hydrogen and oxygen for renewable energy applications. Uh, I'm a bit about me. I'm from Newcastle, grew up here. I did my undergrad at Teesside University down in Middlesbrough, so not too far away. So I'm fairly local to the northeast of England. I guess as far as academics go, I've taken a slightly non-traditional route into it in that I worked in industry for a while. So I finished my bachelor's degree. I then worked in industry in the various chemical industries for around 4 years before deciding to head back into academia in order to do my doctorate. So going from academia into industry and then back into academia, there's a certain skill set that would be required. And there's the sort of obvious ones, as the maths and the science aspect of it. There's also a bit of coding that we need to do, but predominantly the main skill is critical thinking and problem solving. And as scientists, we always strive to solve problems. It's our job. So this is a very, very strong skill that is required. And for me personally, I've actually always been more comfortable in things such as playing my guitar or doing drama. But I was always interested in science and knew that I wanted to pursue a career in science. So developing different ways of looking at the same problem, and when one isn't working, trying something new, changing it up until you eventually uh, come to an understanding of what you're trying to understand, or you come. A bit more about my project. So as I mentioned, I develop materials that can be used to electrochemically, so using electrical power to drive the chemical splitting of water into oxygen and hydrogen gas. Hydrogen, as is famously a exceptionally good fuel, but it is also an exceptionally dangerous fuel, and the storage of hydrogen is a major challenge. So if we can store the hydrogen, for want of a better word, in liquid water, then that would be ideal, because water, as we know, is fairly chemically safe. I would like to challenge you guys at home to do a small experiment and have a think about how you can use different types of energy to drive reactions. So in my project, I use electrical energy or electrical power to drive a chemical reaction. And because this reaction uses energy from the environment around it, it's what is known as an endothermic reaction. But more commonly, endothermic reactions are associated with, heat, as the name suggests. So I'm sure all of you, or most of you, at some point have done or heard about the famous making a volcano out of bicarbonate of soda and vinegar. And you can add the food coloring and it froths up and looks like a volcano with lava. But we associate that with heat because lava, and it looks like it's fizzing. But this is an actual example of an endothermic reaction, and I'd like you guys to prove that. So in our experiment, we are going to use the heat energy in the palm of our hand to drive the reaction between sodium bicarbonate and ethanoic acid, or sodium bicarb and vinegar. This is going to produce water, carbon dioxide gas, and sodium acetate. Okay, so we're going to do this experiment over the sink. The only safety thing to keep in mind is if you have any cuts on your hands, then you should wear some gloves because this is going to sting otherwise. So we've got our bicarb of soda and our vinegar. And all we're going to do is pour a small amount of bicarb of soda into our hands. Then we're going to run the vinegar slowly over it. And you should be able to see the carbon dioxide coming off in the form of bubbles. And as you add vinegar, you can feel the heat energy coming from your hand and driving the experiment, hence why it feels colder. So now that we've proved the reaction to be endothermic, what happens if we change different variables in the experiment? For instance, if we add more bicarb or more vinegar or a different type of vinegar, or we could change the starting environment. Try running your hand under cold water for a bit to make the area cold. Try the reaction, then run it under warm water, make it warm, try the reaction again. See what the difference is. Thank you very much for watching. Bye, I guess. Woo! Science.